I'm very excited to introduce Chenxi as our closing keynote speaker. I met Chenxi about 8 years ago when she was kicking off Rain Capital through a common friend in cybersecurity. And I remember being blown away by her technical expertise, her interest in trying to promote women in tech and cybersecurity, and her strategic thinking around where markets and ecosystems are going. Chenxi is 8 years in now into Rain Capital, which has invested in some of the most bleeding-edge cybersecurity startups. She's the founder and managing partner at Rain. She's also a Fortune 500 board member, as well as a huge advocate of promoting women in tech and security. So Chenxi, welcome.
Thank you. Thank you for having me. I just came off a very busy week at RSA. Now this is my second keynote. Actually, I did a keynote panel at RSA earlier in the week, so that was very interesting. One of the questions that I've been pondering about is, and I'd love to chat with folks in this audience as well, how would software engineering change in the next 5 years? What do you think it will change? How do you think it will change? When we have AI writing code, writing more and more code, how is programming done today? Right? We start with an idea, and we build a logic. We say, okay, we want a programming to do X, then Y, then Z. You know, you think about building if and else statement. It's a pre-built logic. They really should have another screen here, huh? If you're sitting there, you can't really see. So the traditional programming is about idea to design to build the software. I actually built a compiler for my PhD research, so I kind of understand how the code inside of the code works. But you have to have a pre-built logic to then build the code, and that's how it's done today. With AI writing code, there is no pre-built logic. You start with an idea, a goal. You said, I want to build a website that sells clothes. I want to build a calendar app. You just tell the model that that's what you want to do, and you may tell it you want certain things to be done, but there is no if-else statement that you structure. The model itself will build the if-else statement for you. So you go from idea to a prototype today. You can do that in 5 minutes with tools like Bolt, screenshot to code. Those tools take the idea and then use the model that's been trained on many, many different corpus of code, then generate the code that's for your idea. And it works most of the time. You know, it's automated. But most of these tools focus on the front end. They can give you a user interface, and they can take input, and they can generate pretty much what you would expect as output. Now, this is what I call zero to prototype with AI, right? This can be done in 5 minutes. And in this type of application, if you are interested in zero to prototype, today 70 to 90% of the code is written with AI. There's also a slightly different way of using AI for coding is you start with an application already. You already have some lines of code, but you want to enhance it. You want to complete it. You want to write something to add on top. So those tools, Cursor is one of those tools, right? Those tools I call AI sort of is code to faster code. And this is really you bringing these tools to do surgery on your code. And this can be done pretty fast too, right? So you load up an application, and then you start using prompt to ask questions In the back end, the model is processing your lines of code and is understanding the logic that you had in there and is popping up suggestions on things that you want built. Then you can say, hey, I'm going to take this block, I'm taking that block, or you can ask additional questions to enhance the code that's generated by AI. This is from code to finished product, right? Earlier is from code to prototype. Now, in this mode, code to faster code, today, it's about 30 and 40% of the code is written by AI, but is rising, right? The question is, in 5 years, what percentage of the code will be written by AI, not just in the code to prototype, but all the way to back end? It's probably gonna be, my guess is gonna be 90, 95%, including back end, including configuration, including infrastructure as code. And when that happens, the reason I start with this backdrop is how is that going to impact cybersecurity is a question that I've been thinking about. So this, if any of you play with it, this is the screen of Cursor, right? So you have your code on the left, and so Cursor is highlighting blocks of code in the middle, and where I have put the red box is your prompt, right? So the prompt, what I did is explain this code to me like a beginner. Imagine you have an engineer is trying to process somebody else's code, which happens all the time, right? You come on a new job and you have to maintain or understand some of the code, and this is what you would do. You say, explain this code to me as a beginner. And this is what will happen. It'll process the code, and this is what it will jump out. It'll tell you each block what it does. It will even go in to describe the specific properties, say, a React program would need. And this is all generated automatically. And can even generate comments for you for the code, which is super interesting. When I started playing with it, I'm like, this is magic. You know, when I was in grad school, to do this, I had to sit and really understand line by line of code. Then you say, oh, okay, I understand what this block does. And this is done for you automatically. And this is what's called vibe coding, right? So with vibe coding, what is a human's role today? Now, that's a question that I was also interested in exploring. If you think about people who are really, really proficient with tools like Cursor and Klein, what they're doing is they're handling edge cases. Cases that the model's not trained on, or the model is kind of not very proficient at handling. Humans are re-examining architecture choices that are generated by the code. You can say, hey, and I really don't want these different functions to be microservices. They might serve better to be one, monolithic block here. That's the choices you can make as a human. The model will give you one choice, and you can say, hey, go back and give me a different choice. And that is decided by a human. And another case that humans doing today is error handling, right? So you're doing a lot of understand the error and say, hey, what error message should we output? And that's something also the model is kind of lacking. And of course, fixing bugs. Fast forward, when you have 90, 95% of the code written by AI, then what is the human's role is a question that I think is really interesting to look at. The three things that humans will still go in to help AI, I think, when this 90% code is written by AI is reliability. How do we make the application reliable? How do we make the application secure? And how do we really make it scalable? In one of the earlier panels, you saw that it's code to prototype, right? So today you can generate prototype applications really well, but really is the last mile to deployment, how to make it scalable, how to make it robust. A lot of demo quality code falls down when you put it in production, you suddenly have thousands of users hitting that application, then the code just falls on its face. And that's why you need scalability, you need production quality testing. And that's humans may still handle that part. And of course, the question is, when will LLM learn to do security? When will LLM learn to take your sort of demo code and transform it into production quality code that can handle millions of users? And that probably is not that far from reality, right? So we know that LLMs learn from repeated tasks. If you tell it, you did things 9 times, it'll do the 10th time really well for you, and 11th and 12th. But if you haven't seen you doing it, then it will just it'll throw up its hands and say, I don't know. Edge cases are still gonna be a problem. There's a case study I saw in real life, right? There's a low-level threat locking system resource that started locking a block of code that is longer than it should have. And when it does it, it basically violates a high-level concurrency design. And when you go to test that code and the concurrency design just didn't work, and you had no idea why it didn't work, because you didn't know that the low-level locking was done differently. And that is a very rare case, and probably happens, I don't know, once every 5 years. This very experienced programmer told me. So if AI hasn't seen this, once it happens once 5 years, then AI wouldn't know what to look for, and humans still gonna guide this. The question is, how much of the security belongs in edge cases? And I think a lot of security is actually edge cases, because the common cases are already been done and studied by both defenders and attackers. The attacker is gonna move out of the common cases and hit the edge cases so that they're not gonna be caught by the logic that's already understood by AI detection. So the edge cases will remain there, and human oversight will still remain. But let's talk a little bit specifically about application security when you have tools like cursors generating 95% of the code, right? So, and you guys are here because you're interested in cybersecurity. Do you know? Actually, I forgot to ask, how many of you have experimented with it, because it's kind of blinding here. How many of you have experimented with those automatic code generation AI tools? Show of hands. Oh, a lot of, it's pretty good, more than half. Think about when you put in prompt and code come out the other side. When we all live in that world, do we still need this model, this process of scan, development, scan, then reporting, then fix, then rescan? What do you think? Or do you think application security will be very different? I see a hand there. What do you think?
We don't need that.
We don't need that, she says. And what are we gonna need?
What we need is basically, we take the code from there, but we check if it is doing the right thing. And basically, we look for the bugs, right? We look at those things instead of writing code.
She said we are going to take the code from the AI and we check for the bugs. Who's we? Are we humans checking the bugs or the AI checking bugs? Humans checking the bugs. I disagree. I think AI is going to be checking bugs as a first filter. Humans, again, going to be doing the very edge cases that we don't understand. AI will not understand, and will take humans some time to hunt as well. But the process of dev to scan, to triage, to fix is old process. I don't think with AI we're gonna do that. With AI, what will happen is to me, is the opportunity to have true secure by design. So ideally, right, what are we gonna have is an application security assistant. As you are interfacing with AI, you are asking it to generate code. This assistant, which is hopefully part of this environment, will then automatically go and load up, guess what? Load up your PRDs, load up your security policy documents. It'll load up these policy documents for you. We'll load up, where this API come from, and the API documentation, or maybe the security policy for code behind the API. We'll load up all for you and help you generate the code and testing in that moment. So earlier, the guy talked about unit test. Every time you write an AI agent, you want to do unit test. I think the AI security assistant will do unit tests for you in your IDE, and that's the ideal scenario to happen. So agentic AI, agentic application security is what I'm thinking about. Is absolutely have to happen. It's proactive and automatic. Okay? So my view, today, only 20% of organizations I talk to are actually serious users of those AI generation tools. 80% are just tourists. But more than half, actually today, less than half of the organizations of these 20% serious users have any kind of secure coding governance that is attached to the AI models. That's what we need. We need to have secure coding guideline as part of the AI policies, as part of the AI agentic assistant for you, so that we have true secure by design. When you generating code, when it comes out of your machine, goes into the repo or integrated with your next engineer's repo, it's already been tested and secure and been verified. And how far are we from that vision? We're actually pretty far. But the future of AppSec is agentic. It can understand natural language. It can execute actions from your IDE to APIs. It can action fixes in real time. And that, let's see. Yeah, so this is one of my desktop assistant that I use called Ventrilo. Every time that it looks across all my tabs and understand what I'm doing in the other tab and gives me context for the task at hand. And this is the future of assistant, and this is not an application security assistant. I'm just putting there to give you an idea that in the future, your assistant will work across policies, work across even maybe organizations to give you the right context to make the decision. Okay, so this is just an example to let me know that I can put these text in an email that I'm writing, and the text came from the other tab that I had opened earlier, which is super cool. A big question is hallucination. How do we deal with it? Human validation built-in loop and best of N, which is a validation test method that your agent can execute. All right, pulling it all together. We don't have a lot of time left. We have, my view, I'm an AI enthusiast security person. AI will code more, will code faster, and will code gradually more securely. And there will be less for application security engineers to do. And will application security engineers go away? I don't think so. Their job will just be more interesting. Hopefully they don't have to deal with cross-site scripting errors, but they will deal with the insidious edge cases that nobody thought about. So longer term, right, again, humans focus only on rare and sophisticated edge cases, and I think we need less humans, but more interesting work with AI as part of the secure by design coding system. Some of the innovation opportunities, right? If you're doing a startup or interested in startups, this is the type of items that you should be thinking about. I'm thinking about it. Agentic application security functions, human validation in the loop. How do I build that in? That's actually not easy to do, right? Who should validate? How many people should validate? And how do we deal with exceptions? All these things need to be built. And continue to develop and refine an edge case corpus of knowledge as part of your coding model. You can gradually build more and more edge case knowledge into the coding model. And then we'll have a very, very smart, secure coding AI model. So with that is my contact information. Love to have this conversation, continue this conversation after the session. We are at time, so no questions. Okay, we take questions offline, but you have my contact info, so send me an email or ping me on LinkedIn, okay?